All right, it is 1:30, and I'm going to go ahead and get started because I want to leave some time at the end for Q&A. I tend to cover a lot when I talk about virtual reality because it is something I am very, very excited and very, very passionate about, and I want to make sure that there's some time at the end to cover some of the stuff that I won't think to talk about in my talk. I'll start off by introducing myself. I'm Erickson, and I am a virtual and augmented reality developer evangelist at Microsoft. I'm based out of the San Francisco Bay Area as of 3 years ago, but I've spent a lot of time in Philadelphia. My grandparents live here, so I'm really excited to be back talking to you all today. I get a lot of people ask me, like, what exactly is a developer evangelist for VR and AR? And the short version of my job title is that I get to play with immersive technology and then teach other people how they can start learning about developing, designing, and building for VR and AR technologies. And this is something that's happened relatively recently. About 2 years ago, I saw a video on YouTube of the Oculus Rift and pretty much said, I need to drop everything that I'm doing and go learn about virtual reality and get into this industry. So I've been working as a VR, AR developer evangelist for about 2 years now. And I'm going to talk to you today about what the kind of immersive technology in 2016 looks like. What does it mean when we talk about VR? And if you're not a gamer, why do you really care? It's another big question I get a lot. And I was not a gamer until I started playing with VR. I had, a Nintendo when I was a kid, so I liked video games, but I never considered myself a gamer. I wasn't sure that VR was going to be for me, or that there'd be applications for me to be using virtual and augmented reality outside of gaming to start with. But I'm going to talk a little bit about the ecosystem as it stands right now, and talk a little bit about how people are using VR outside of the gaming industry and how you can get started building virtual and augmented reality applications today. Following that, I think examples are really cool and more interesting than PowerPoint slides. So I'm going to walk you through one of my virtual reality applications that I built, which is a proof of concept for an Excel chart virtual reality generator. And you'll get to walk through data in a new way. I personally have never been the most fond of reading spreadsheets, so this is one of the things I wanted to do when I was testing out the virtual reality web platform and web framework. I'm going to share with you all today how I did that and answer questions about what you want to know about VR. So I like to start off here. Who is already working in a virtual reality application or on an application? Perfect, a couple of you. So that's great, because every time I go, and I used to first start doing these talks, no one would raise their hand, and every time I do it, I see just a couple more people who are starting to talk about it. So for some of you, you'll be kind of familiar with what this first part of the talk covers. For others, it'll be totally new and hopefully exciting. I'm guessing you're all here because you're a little bit excited or interested. So it's been the year of virtual reality for about 4 years now, not counting all the times that we did this already and learned from it in the past. Back in 2012, the first version of the Oculus developer kit pretty much broke a lot of Kickstarter records, and Palmer Luckey announced that we were having this new wave of VR technology. As I mentioned, we've said this quite a few years now, 2014 is going to be the year of VR. And when that didn't happen, it was like, well, no, that's okay. It's 2015 will be the year. And now I'm here to say 2016 is the year of VR, I hope. But what we've seen here over the past 4 years is that interest in virtual and augmented reality has grown substantially. Market estimates change a lot depending on who you ask, but a lot of the estimates I see are in the range of virtual and augmented reality as an industry being worth about $120 to $150 billion by 2020. That's big. That's about a third of the size of the current mobile industry right now, also very large. But you can see here, I'm not going to go into all of these different devices and list these off and talk about the differences. If you want to ask me about them, come find me afterwards and I will rant your ear off about these devices. But you can see here that there's been a trend in terms of hardware and platform growth in the VR and AR industries over the last 4 years. A lot of people, when they hear VR, they think Google Cardboard or Oculus Rift, Google Glass for augmented and mixed reality, HoloLens. And those are some of the big names, but there's a lot more going on in terms of bringing different levels of virtual reality content to consumers. Who here has or has used a cardboard headset before? Most, maybe about half, a little bit over half. And I have to admit, the first time I saw cardboard, it was kind of funny. My friends came home from Google I/O and they said, oh, I have this cardboard box that's going to turn into a VR headset. Everyone's kind of like, what? Really? And it's actually been stunningly successful in terms of the number of units that they've shipped. The last count, as of about 6 months ago, was over 500 million units, and they believe that that's been growing. But things are changing rapidly. Numbers change a lot. Estimates change a lot. 2 weeks ago, something really big and exciting happened, and that is that both of the desktop consumer virtual reality devices launched their headsets and started shipping those at the end of March. So that dream that we had of desktop VR back in 2012 is finally starting to ship out to consumers today. You can go online, pre-order your very own room-scale VR device and have it sometime between April and August, depending on your ship date. And we're starting to see these platforms are enabling a lot more virtual reality content than we've seen in the past. To put it in perspective, Stanford recently re-outfitted their VR lab with Oculus Rifts. And the consumer version of the Oculus Rift costs about $600. When they first kind of built out this lab in the 90s, each of their VR devices cost about $40,000. So you can kind of get a sense of the difference in scaling down the price and availability and how that's starting to make virtual reality a lot more feasible in today's technical ecosystem. So when we talk about today's immersive technology ecosystem, we generally will talk about things that fall into one of these three categories. And depending on who you ask, this will grow or this will shrink. I've heard a lot of different, insert letter in front of R to describe some very niche technology. I've heard someone start saying RR to designate like real reality. But this is kind of the terminology that I'll use today in terms of the virtual, augmented, and mixed reality ecosystem. Now, to some extent, these are all just variations on a spectrum of immersive content. Virtual reality, such as a device such as the Oculus Rift, a cardboard, Gear VR, it's going to fully immerse you into another experience. You're generally not going to be experiencing what's going on in your physical world at the same time as being in a virtual environment. Instead, VR will kind of take you away and transport you somewhere else. When you do an experience or a demo given by Oculus, the attendants will say to you when you finish, welcome back. They don't say like, oh, okay, your game is over, like, now you're done. They say, welcome back, because that sense of being somewhere else in VR is really what the technology is all about. On the opposite end of that, you have augmented and mixed reality. Augmented reality, such as a Google Glass device, will overlay digital information in the physical world to help you understand that physical world a little bit better. Examples of this may be map applications. If I'm standing on a street and I'm telling my headset, my augmented reality headset, where I want to go, it may lay out a yellow brick road for me to follow to my destination. And then alongside augmented reality, you have mixed reality, which is something like the HoloLens. And what this does is it's like augmented reality in that it's bringing in digital information to your world, but those digital objects may or may not have anything to do with your physical surroundings. Perhaps you have a virtual kitten that runs around your living room. That data isn't necessarily enhancing or teaching you about your surroundings, but it's overlaying that digital information into your physical world to create a mixed type of reality that blends digital and physical together. So let's talk a little bit about a head-mounted display. Generally speaking, there are several different ways that you can build VR and AR ecosystems out, but right now, head-mounted displays are really, really popular, and they're the ones that have been focused on recently. You may be familiar with kind of room systems that have multiple projectors set up as cave and room scale virtual reality systems. And those are still in use. They're still getting explored. But I'm going to talk to you specifically about head-mounted display virtual reality technology because that's what I've been exploring myself. So at the very, very end of this kind of head-mounted display spectrum, you have mobile head-mounted displays. An example of this might be the Google Cardboard, the Gear VR. There are a whole bunch of different options that kind of fall between the Gear VR and the Google Cardboard in terms of the phone that you may have that you're powering your device with. If you go on Amazon and search for virtual reality headsets, you might be surprised with how many different options you have. And that's going to be something that you see like this right here. This is a Samsung Gear VR, and it's powered by Samsung's flagship 2015 and 2016 phones. And the basic principle behind a mobile head-mounted display, as you may have guessed, is that it is powered by a mobile phone. This device is a casing that you have for your virtual reality experience, and it's got some pretty cool sensors in here in terms of tracking your head position. But really what it is it's a set of lenses in a device that holds your phone to your face. So if you've tried cardboard, you're aware that you can actually build some pretty compelling virtual reality experiences powered by mobile devices using a cardboard box and specialized lenses. As I mentioned, there's a range of different devices that range in quality and experience for your mobile phone. But with a mobile head-mounted display, you don't actually have a separate display in the headset. Your phone acts as the processor, the graphics renderer, the application will run on your mobile phone, and really, the only specialized thing that you have in that headset could be the lenses, or you could add additional sensors to it. I'm going to show you a video a little later on of a WebVR site that's rendered on a mobile VR headset. But you kind of start to see that at the lower end of virtual reality technology right now, you have your cell phone and your display, or your head device. When you go to the next level of head-mounted displays, you get into the area of desktop head-mounted displays. And this is going to be something like the Oculus Rift, the HTC Vive, or the Fove headset, which isn't released yet. These devices are all powered by the computer that you're running them on. So there's some obvious upsides and obvious downsides to this. One being you're tethered to a computer. That's a kind of a substantial challenge when you want to have free roaming virtual reality experiences. But with things like the HTC Vive, those are starting to become more and more feasible despite being tethered to the computer. As an upside with desktop virtual reality, you get a significantly better experience because you can put in much more powerful hardware to power the experiences that you're showing. When you do graphics rendering, especially at the frame rates that virtual reality requires to be really compelling, that extra hardware goes a long way in making that experience crisp and clear and really adding to the sense of immersion that you have of being in a different place. With desktop head-mounted displays, the downside to all of that hardware is cost. You do have to have pretty significantly powerful systems to power desktop VR devices, which is why I have a mobile device with me and not a desktop one, because my laptop is not going to run that very happily. But improvements are happening, and they're actually building a lot of laptops now that are able to power VR experiences with full desktop-grade graphics cards. And then lastly, we're getting into a category of standalone head-mounted displays. And these are completely self-contained devices that will render to a screen in front of you. All of the processing, all of the running of the applications, graphics rendering is all done on this device itself. You are not tethered to anything. The whole entire device powers everything. You're essentially wearing an entire computer on your head. And if you thought that the price for the desktop devices were probably pretty high, as I mentioned, they're significantly cheaper than they used to be, but when you look at miniaturizing all of that and sticking it into a headset, you're going to see that this is at the kind of upper end of the spectrum in terms of cost, but you get the benefits of the mobile VR headset without needing to be tethered to the desktop or have multiple different devices for your experience. So let's talk a little bit about those experiences. Why would you even bother doing 3D computing in the first place? There are a lot of things that make virtual and augmented reality really compelling. The first is around storytelling. At its core, a lot of what we do as humans is telling stories to accomplish problem solving and figuring out how to make tasks easier, how to perform them better, how to fix things. And when you can tell that story in a way that relates back to what we as human beings are able to relate to, it becomes significantly more powerful, and you would get a lot more empathy from the people that you're talking to. I've kind of had a lot of experiences where, if I'm watching the news on the TV, I'm not always paying 100% attention to what's happening on the news. I'm distracted by everything else kind of going on in the world. I'm watching that story as it's happened to someone else. With virtual reality, that experience changes. I'm not distracted by my physical environment. I'm entirely present in that experience. And I'm not just watching it happen to someone else. I'm experiencing what that actually is like to be in. And this is really powerful for things like journalism and telling stories if you're trying to raise awareness for different causes. If you're trying to showcase specific topics, being able to talk to someone and have them experience that the way that you experience that is incredibly powerful. I mentioned this one a little bit, visualizations of complex data. Machine learning, big data, processing all of that information that we've been doing analytics on for decades is challenging. I don't do well, as I mentioned, reading things, numbers off of a spreadsheet, numbers, letters. I can read through them, but it's hard to kind of relate those back to each other and make really big decisions about what I'm working on and how all of the different pieces of data relate back together. And 3D visualizations of complex data can help make those problems a lot more relatable. I'm not a number that exists on a page, and I have a hard time relating to numbers that exist in pages. But when I can represent my data about how much money that I'm spending or how much money my team is going to need for a project, and I can visualize that in stacks of dollar bills, that is something that I can internalize. I can relate to that. Virtual and augmented reality enables new ways of interacting with all of this technical stuff that we've been building for years. The Internet of Things is one of those really cool areas of technology where we're getting so many cloud-connected devices that we can go and interact with. And that's really helping bridge our digital and physical worlds together. And virtual reality adds another layer on top of that. Like I said, if I wanted to pop on my VR headset when I'm at work and I'm at home and I can tell my stove what to do to help prepare dinner, I'm blending in that ecosystem of IoT and visualization and being able to interact with something in a way that I'm used to. I don't have to fumble through layers of an application that may or may not be intuitive to me. I use a lot of apps on a regular basis, and I'm guessing all of you do too. So you start to have this physical way of interacting with information that right now exists only on a 2D screen that we carry around with us. And this makes computing more intuitive. When I think about files that I have, if I'm thinking of a physical file folder, I can generally think, oh, I probably left that on my desk or on the kitchen table or maybe on the sofa. It's in one of those 3 places. But if I'm thinking of where I put a file on one of my 3 cloud accounts that I'm connected to any given day, one, it speaks a little bit to my technical organization skills, which I always am working on, but I know a lot of people kind of struggle to visualize what the file system looks like, and virtual reality has that intuitive computing. If there's any fans of the show Community in here, you may have seen the VR experience where all of his files are represented in virtual file folders. I'm not sure that that's the right solution for VR and being able to interact with that data, but we're starting to see this bridge between how we think about stuff spatially in the physical world and being able to think about things spatially in the digital world. So generally, when we talk about types of virtual reality and immersive applications, there are a few different things that you can think about. There are a few different ways you can capture this content and create applications. And I'm going to talk a little bit about those right now, as well as some of the trade-offs. So when you think about something that you've seen in a virtual reality app, if you've experienced it, and if you haven't, come find me afterwards, because I'd be happy to give you a demo. You probably have seen a 360-degree photo or video, maybe on Facebook or on YouTube, on some kind of, if you're just looking around the internet, this is probably something you've come across, and it will let you look around from a photo that's been taken that captures not just one direction, but the whole entire environment around you. These can be recorded on specialized camera rigs or on a series of cameras that are stuck together in a circle to capture the entire environment. And what this allows you to do is it allows you to capture real events and real spaces from one perspective. It has a pretty low cost to entry. You can take photos, 360 photos on your cell phone now, and it'll stitch together automatically, and you can put that in a viewer and look around and have a really easy VR version of the environment that you're in. But you can also, it also has, when you're capturing the video, a lot higher of a cost when you're capturing and streaming and stitching something together in real time. You also have the downside that you can't actively move around from different perspectives. So if I were to film something in 360 from my perspective, I wouldn't know what it was like to sit in the audience and watch. Volumeography is another version of a virtual reality application that will let you capture a space and reconstruct that into a 3D object. The viewer is still passively experiencing something that someone else has already captured, but they're able to do it from different perspectives. If you capture and recreate something based on the measurements that you're taking, and you're using a lot of CGI to then generate that space out, it's higher complexity in terms of computational power, and it's a little bit more challenging to capture large spaces and dynamic experiences than a 360 video might be, but you're adding that level of movement into the scene. Someone can go around and explore different perspectives. A volumetric capture of this presentation, I could go over and see what it was like to watch from the back of the stage. Say, maybe don't hold up those things anymore, Olivia, it's hard to see. And then lastly, you have real-time computer-generated experiences. This tends to be primarily what I focus on. So I'm going to show you an example of this type of virtual reality today. And again, it's got its trade-offs. Your entire experience can be created through 3D programming. The viewer can either passively watch an experience that's been created, or they can interactively manipulate that. So video games have been using 3D CGI for a very long time, and now with virtual reality, you can apply that technology to all sorts of different applications. And you can mix these around together too. I've seen some really interesting applications of volumetric capture that then have different augmented data on top of the captured experience so that it provides more information than someone may get if they were just looking at the pure volumetric capture. With real-time CGI, you can have a 360 video playing as your backdrop and then add different characters or elements into your scene. So these aren't entirely just standalone experiences. You can have applications that are a blend of both. Real-time CGI, again, since it's all computer generated, it can be very, very expensive if you're rendering incredibly realistic environments that have a lot of complex interactions. But you can also prototype experiences really, really quickly with a variety of different tools. With CGI, pure CGI, it can be harder to reconstruct the level of detail that you can capture with volumography. So you start to see some different blends of how these all come together to create immersive experiences. So from a development perspective, what does getting started with virtual and augmented reality development even look like today? From the platform perspective, you've got the same options that you have right now when you're deciding how to build out a product already. You have the option to build native applications, which are generally more powerful and can harness the full computer hardware that you're using or device hardware that you're using. You have the ability to create mobile applications, which are more accessible to people who may have a cardboard but not an Oculus. They're distributed through app stores like any of the apps that you may use today. And you also have the opportunity to build virtual reality web applications. These are great for proof of concept applications like the one that I'll show you, but you get a little bit of a performance hit with the non-native graphics that you're using, and you have a little bit of an easier time integrating existing content into those types of applications. Full disclaimer, my background is not in web development. I started learning web development because I was really excited about the opportunity presented by the VR web. But I've always had a much easier time integrating APIs and all of the existing web content that already exists into a web application than trying to pull it out and play with it in a native format. Trying to parse through a JavaScript REST API in C++ or C can be challenging, at least for me. When you look at the development tool sets, some of them are very, very straightforward, like web development. Some of them you may not have heard of if you've never done gaming or 3D development. A very popular choice for developing virtual reality applications are using 3D game engines, such as Unity, Unreal, or CryEngine. These offload a lot of the things that you need to think about when you're building a 3D application, like lighting and rendering, physics, character movement, and they provide templates built in so that you don't have to recreate the wheel with that in your application. The downside of that is you do get a little bit less fine control over that, but you can also play around a lot with kind of the defaults there to give it the performance and customization that you need. You won't get the same exact degree of control as if you were writing your entire engine from the ground up natively, but that is, of course, an option for virtual reality development as well. With native programming, you'll be writing DirectX, OpenGL, Java, or any of the mobile derivatives of that if you're looking at building an Android or iOS application specifically in their target frameworks. And then you have the web. With the web VR, you have several options at this stage. Virtual reality markup languages have been around for a while, and they're getting even more powerful. 3JS is a JavaScript library that does 3D graphics. There's a WebGL, and building on top of WebGL and using some WebVR API templates, you can build really powerful web experiences. And again, this is why I like to show the demo, because it's not going to do it justice just talking about it today. But you also have really simple languages like A-Frame that will allow you to, within like 2 or 3 lines of markup styled language, prototype WebVR experiences in your browser. So going back to the industry and looking at some of the examples, again, I've asked that question, I'm not a gamer, why do I care about virtual reality? One of the big areas that VR is starting to see some growth in is in the advertising sector. This picture is a picture from Volvo and their Google Play Store experience, where they bring the experience of attending their showroom and driving their cars into a virtual reality application available on the Play Store. So you have branded headsets in here, branded experiences, sponsored content that showcase specific things that are very hard for someone to just experience from their house. I don't know what it's like to go to a showroom and drive 20 different types of cars, but with virtual reality, I can do all of that from my apartment. It won't be exactly the same, but I'll be able to get a feel for what those experiences are like and what that brand is like. You've got anything from kind of showcase brand experiences, like this one here, to a short-term video, maybe 15 seconds of content, or an in-application advertisement with virtual product placement or in-world billboards. And as you can imagine, there's a lot of money in advertising, and that tends to be one of the places that's starting to see a lot of growth in virtual reality today. Immersive training is another aspect. I've mentioned a little bit that ability to interact with things spatially the way we do in the physical world. Having that ability to learn about a lot of different content in virtual settings makes training cheaper and a lot faster and more accessible. So we've seen flight simulators as an example of this that have been around for quite a while. And we're starting to see really successful training in the medical industry as well. Mechanics being able to teach people how to change tires or how to fix a bicycle problem. Being able to watch that in 3D and experience it as you're kind of working on your own application in the physical world can be incredibly helpful. You also have the ability to simulate cases that are really challenging to predict in the world. Things like virtual weather conditions. If you're training someone in a very specific environment, you may or may not have the ability to try seeing what it would be like to train, race car driving in snow or football practice in rain. I know I have lived in California now for 3 years, and we don't see a lot of rain. So if I can virtually experience something with different weather conditions as part of my training, I'll be more prepared for environments that I may or may not be able to see too much in my physical world. And then you can also control different variables in your simulations and predict and work through hard to predict or low likelihood occurrences. Architecture and engineering, particularly architecture, is a big place that's exploring both virtual and augmented reality tooling for their workflow. You can visualize 3D models and walk around within different blueprints that you're building out. There's a company called Iris VR that's working on doing architectural visualization in virtual reality. You can augment plans over the physical building so that if you're standing on your job site, you can look at what it looks like to stand there and say, okay, put on the headset, that's where this wall is going to go, we have a door here. You can walk through your house before it's built or see what different finishes would look like on the wall. Maybe you build out this beautiful application and realize that the staircase, you just hate where it's placed and you want to move that. It's really a lot better to know that before you start building. So again, you start to have these immersive experiences and new ways of exploring information that lowers cost to fixing things along the road as things are being done and houses, buildings are being built. I've mentioned the medical industry and specifically med school training, but you also have the ability with virtual reality to start looking at medical imagery that's been reconstructed. There's a really, for me, interesting application of this technology in Google Cardboard when surgeons, for the first time, were able to walk through a newborn baby's heart that had been captured in 3D and they could actually view that in VR and look around the inside of this heart to find where the problem was and save the baby's life. For me, that's kind of like a really big wow moment that this technology is being used today to help save lives, but also to just rethink how we're learning more about the world around us too. I've mentioned surgical training and being able to augment virtual surgery. I don't think that there are any cases of that have been done yet, but they're working on building out experiences so that with kind of the robotics industry, you can build applications that can be used remotely through augmented and virtual reality. I believe I read an article today actually that says that they were broadcasting a surgery in VR for the first time sometime this week, so that students who have never been able to perform the surgery can actually watch a surgeon doing it in real time and experience what that's like. Something that's space prohibitive today for a lot of applications. So with that, I'm going to talk a little bit specifically, diving deeper into the VR web. I built this originally about a year ago, and I've been playing around with it and updating it throughout the last year. But I had this idea that I really wanted to make my data easier to read and easier to understand. And so with that, I was exploring the virtual reality web. What the VR web, and specifically the WebVR API, which is an experimental API that's being built right now, what it allows you to do is build multi-platform virtual reality applications that will work on both desktop and mobile devices. You don't have to build and compile to different devices. Since they run in the browser, they just usually work. You can seamlessly transition with WebVR between VR and non-VR modes. And depending on the integration in your browser, you may or may not have support for VR at this point on the desktop. But everybody's mobile phone can run a VR-enabled website in virtual reality mode today. As I mentioned, it will let you utilize existing web libraries, and it's built on top of WebGL and the WebGL canvassing system. So what I built today was the first kind of prototype into data visualization in VR. I've said this a couple of times now, I think. Excel graphs, challenging for me to read and understand. So I built this on top of the .NET framework that uses Three.js for the front-end visualization, and I used the WebVR library for stereoscopic rendering and tracking. What we do, and I'll show you in just a second, is you parse through Excel data, and we're going to convert it to JSON. We're going to grab the values from the converted JSON and create a 3D scene based on that JSON value. And then as we're using this in our VR device, it will update our position within the scene so that we can treat it like a virtual reality environment. Basic steps with a WebVR template, and I'll show you the code behind this in just a second because I think the code is cool. You're going to set up a WebGL canvas to be rendering all of your 3D objects to. We're going to create a Three.js scene. We're going to apply the VR controls to the camera so that when our headset is moving around, we'll be able to look in different positions. We're going to add the VR effect so that it's rendered stereoscopically when we enter virtual reality mode. We include a manager that will switch between those modes because not everybody has a VR device, and we want to build something that works seamlessly. We're going to create our objects within that scene based on the JSON that we went through, and then we'll update our display loop in our request animation frame function so that it updates every time the frame rate goes. So let's see it in action. And I'll have those links up at the end so you don't have to try to rush to grab those. The first thing that I'm going to show you is I'm going to show you a quick video because, as I mentioned, that's not presenting. All right. So I've got a video, and this is from my phone. And what I just do here is this is what I'm going to show you I've built on a mobile device. So I use Bootstrap, basic front-end website, and a drop-down menu that lets me pick multiple Excel spreadsheets. You can upload Excel spreadsheets to this, but I have a sample one in there that I like to use just in case. So I'm moving the phone around, and I'm getting a different perspective, and then I'll enter VR mode, and everything is rendered stereoscopically. And there's actually not a ton of code that I wrote because there's a really powerful WebVR framework that I use that just lets me focus on the experience itself that I'm building more than worrying about if I'm rendering things stereoscopically. So the slide that I just showed you is a visualization of housing prices in San Francisco compared to different places in the rest of the world. It's expensive to live in San Francisco, but when I look at numbers, it's hard to kind of internalize what those all mean together. So I'm going to go ahead and just jump into here, and I'm going to show you what it looks like on a non-VR browser so you can get a sense of what we're actually looking at here. So I'm going to come in here and pull up my cost of living Excel spreadsheet, and you can see that I just have this really simple canvas that shows all these differences here. San Francisco, I believe, is about $750 per square foot here. And you can walk around within the scene and look at how this compares to other cities in North Carolina. My parents retired to Bellhaven, and it's much cheaper there than San Francisco. But you can even look here, and I didn't realize this is the average cost per square foot in New York City is so much lower than San Francisco right now. So now we want to see the code, right? I hope so. So I'm just going to stop this. And I'm using .NET, but you can use any kind of framework you want here in terms of building out your WebVR experience. At its core, it's built on top of standard JavaScript, a little bit of jQuery thrown in there, but the library and boilerplate handles a lot of what you're going to have to worry about from a rendering perspective. So you can really focus on that content and writing in a language you may already be familiar with. So if you're not familiar with .NET, we've got a ASPX file here that'll be our the equivalent of our .html files that we would be doing if we were not using a .NET application. And then each of those pages has a little bit of code behind it. The really fun stuff, though, I'll go into is in the page scripts file, which is what renders everything using the WebVR template. Just to give a tiny bit of background here, this is our default page where we have a drop-down object. And then once we have selected our file that we're going to visualize, it's going to call this function behind it here in the upload button click that's going to grab the path of the file that we're uploading or the path of the sample file if you're choosing one of those from the dropdown. And then it's going to create a JSON file from that. Once it's done that, it's going to pass it into our second page, visualizer.aspx. And what I've done here is I've included quite a few helper function files at the top here. We are importing our 3.js file. I mentioned this is the graphics library that I used for this experience. And this is what's going to render everything into our canvas. They've got support for a lot of your basic graphics geometry, materials, textures, lighting, etc. On top of that, we're going to bring in these different components of the WebVR template. We've got a VR controls file, which is going to grab the VR hardware, pass it through the browser, and update everything based on where our head is looking. We're going to render, as I mentioned, stereoscopically with the VR effect file. And then we've got this device polyfill, that, the WebVR polyfill, that's going to fix the effect if we don't have a browser or device that is currently supported by a VR headset. Once we do that, we pull in the manager, which is going to handle switching in and out of those applications, as I mentioned. And we bring in our pagescripts.js file, which is the one that's going to pull all that together and actually render all of the 3D graphics. Once we do that, I grab this JSON file from our code behind that's converted all of our Excel data into a JSON string. And then when the document is all loaded up, I'm going to call paint canvas on that JSON string. Paint canvas is in PageScripts. I apologize for my massive function here. I mentioned I was not a web developer by trade. I'm working on cleaning it up slowly but surely. And so right here you can see the code around. The first thing that we're going to do is we're going to grab that renderer. And if you've done standard WebGL programming, this is just a standard WebGL canvas. And we're going to go ahead and set that to the device size of the window so we don't have some teeny tiny little canvas that everything is drawing on the desktop, or only see the top corner of it on mobile. Once we do that, we're going to create that canvas and append it into our page so that we can actually see it. And then this is where the fun stuff starts. We're going to build a 3JS scene using var scene equals 3scene. And then we'll create a camera that will act as our viewer's eyes into the scene. So when we look at this on the desktop, the camera is going to be what's visualizing everything on the screen. In the VR headset, we essentially will become the camera, and that camera will be reflective of everything that we can see in that device. We create the effect, and we set the effect to apply to the entire window size, and then we apply the virtual reality manager to that. And what this will do is, again, when this little button on the bottom, I don't know if I showed that if that was visible in the video, but what it'll do is it'll include a little button at the bottom of the screen. And when, by default, it's not going to enter you into VR mode because generally there's nothing right now that's linking all of these WebVR sites together. So It assumes you're navigating in a standard browser, load up the WebVR content, enter VR mode, and the manager will switch you over. Once we've done this, we can start adding in all of the different objects that we want to. So for me, I took that Excel graph and I just added some cubes. But if you were going to build an application that let you visualize different environments, you could create meshes here, load those in, load those objects in, define really intricate character behaviors if you want it to be reactive, and basically whatever you can imagine. So what we're going to do here is we go through and we parse that JSON object. And to start with, what we're going to do is we're going to grab out the different keys from each of those objects, which we see here in getting this data set, and var keys equals object.keys. This is essentially going to return back a list of all of the different locations in the graph, because I'm assuming it's formatted the way that I built the graph to be. So down here in the output, you can see what we're working with here in terms of the file data. And you can see, this is really tiny. I don't know if that's going to get any bigger. But trust me, there's data there. And we're going to go through each of those, and we're going to use that data to create our geometry. With 3D development, generally with each of your objects, you're going to want to have the geometry, which is the shape that it contains. You're going to want to have the material, which is how it renders, and then potentially a texture, which will display like the specifics of the image that might be on it, or any kind of like colors, visualizations there. But to keep it kind of simple, we're just building a really basic cube using a regular material that's included with the Three.js library. And so here, what we've gone ahead and done is we also create this geometry based on the data set Y values. So any of the price per square foot data that we get in my example will be converted into a Y value for our box. And then we're just going to position them all together, and it will go on through all of the data sets. So if I go back in and change this information and update it, or if I was pulling it from a site that had live updates on their information, we could do that too. Next, we're going to add in text geometry. I added very, very minimal labels to my code, but you could use this text geometry to create all sorts of different information about different visualizations that you want to build. I show this in a basic chart format, but there's no reason you couldn't use this type of visualization technique to visualize map data, visualize line graphs, all sorts of different, over time experiences. This is a very, very basic idea of what you could do with WebVR right now. So once you do that, we're going to position the text attached to each of those data points so that you actually know what you're looking at. And then we're going to add in all of that data into our scene. So for every cube and every text item in our graph, we add an object to our scene. And then we go ahead and do that for each object. Once we've done that, again, I mentioned you can build out as many types of things as you want in terms of your environment. I add a landing plane, so you have something to walk around on that kind of keeps you grounded as a horizon point. And I just make a really basic plane mesh using the built-in Three.js geometry. And then I'll go ahead and put that into our environment as well. Here we add in this code that will check if we're in VR mode, and if we are in VR mode, we'll render it with the virtual reality effect. And if we are not, we're just going to render it with the standard WebGL canvas renderer that's built in. Our update function, or our animate function, is going to be what updates our headset position, because every time we turn and look somewhere else, we want the camera to move with us. So within our animate function, we're going to be calling this every frame, and the controls will update and apply that effect to our camera. And then again, we'll check, did we leave or enter VR mode? And if so, we'll apply the correct distortion appropriately. I basically added in a very simple movement script that will let you kind of walk around, because as I mentioned, most VR systems today don't provide that functionality, with the exception of what's provided with the HTC Vive Lighthouse system. But I'm expecting we'll see more and more of that supported as the technology matures. So for now, I built a really basic movement script that just walks around with the WASD keys. And again, it's a standard. If you've been used to working with websites before, you're grabbing the key code and then applying a specific function there. So that's basically a really quick overview of what goes into building a VR web experience. Who thinks that they might be able to do something like that? All right, good. That looks optimistic. It could be everyone. If anyone has questions about getting that done, let me know. I don't know why this isn't projecting my PowerPoint anymore. That's okay, we'll duplicate it. So with that, the Excel visualizer that I wrote is hosted online, and it is the first web link there, webvr.azurewebsites.net. If you want to play around with the WebVR template yourself, you can grab that on GitHub. And if you just want to peek around at kind of the orientation there, the WebVR documentation is at webvr.info. I'll leave these slides up for just a little bit longer, but we've got about 15 minutes that I wanted to leave open for questions. We've got a microphone up here. If you want to ask a question, please do so into the microphone. And if you want a demo, come find me afterwards, and I can put you in the Gear VR. Thank you.
Thanks. So I guess my question is really around, with the different hardware that's available right now, and there's more coming along. Is there any kind of standardization happening in the development level? So are there libraries? Is there any kind of open standards that are across the industry, or is the kind of the library and the software that you choose more dependent upon, in the case of like say VR stuff that's hooked up to a PC, based on the hardware that's running in the PC as opposed to the VR headset?
Yeah, so there are, as I kind of went through in the talk, a few different approaches you can take to VR development. So there is a kind of a movement that's a lot of hardware manufacturers are getting on board with in terms of using open sourced libraries for creating kind of a common runtime for all of their experiences. However, not every manufacturer is supporting that because they can get better performance generally at this stage when they are working really closely with their individual hardware. So their SDK is optimized for whatever they're running on their own devices. But as a developer, you don't necessarily need to go that deep in terms of building the different experiences out. So Valve has open sourced some of their libraries, the compiled binaries for their libraries, so that people can build on top of the OpenVR platform and support different devices there and support any applications that are built against OpenVR. There's also the Open Source Virtual Reality Initiative, OSVR, that is looking to have all of the code open source as well. And being able to kind of build on top of those different frameworks generally will give you some flexibility in terms of the devices that you're supporting. When you're looking at kind of a standardization across mobile hardware and desktop hardware, you get a little bit more of a challenge there because of the different architectures. And generally the different availability that you have to peripheral devices and performance and the hardware that's underlying it and where you get capped at performance. But that said, I mentioned some of the things like WebVR, the game engines like Unity and Unreal, they're doing a lot to offload the differences from an individual device perspective so that you can actually go in, build 95% of your application using a game engine or using something like the WebVR platform, and then have a very small amount of that code switch between different checks for the specific individual platforms. So you can still do a lot with optimizing for each of those individual devices and specifically the peripherals that they may support, but you also don't have to reinvent the entire application based on the architecture.
Thanks. Is there a magic number for how long, in hours or whatever, someone can be wearing a headset, before they get nauseous?
That's a really interesting question, and there's not a ton of hard data out there. So what I'll tell you is a little bit anecdotal. So I actually just recently read a statistic this morning from a VR event that's happening in New York right now, how with something like the cardboard experience, generally viewers will stay in those for about 2 to 5 minutes. When you look at the larger scale desktop systems, I know people who have spent 12 or more hours in there and they just completely lose track of how much time they've spent in the VR system. Time dilation in VR is a really interesting thing that we're just kind of starting to explore in the industry due to the number of people who are like, I thought I was playing for 10 minutes and it was 4 hours and I lost all this time in my day. A lot of the higher end systems have made a lot of hardware improvements to minimize motion sickness as much as possible, but there still is a lot depending on the developers themselves to not make experiences that go against best practices for keeping kind of someone who's viewing everything in this experience, keeping them grounded and making sure that they're not spinning them out of control ridiculously. When we first started building VR apps, a lot of people would try doing roller coasters, and it turns out roller coasters make you motion sick in real life. They also make you motion sick in VR. Some people are okay with that. Some people are like, yeah, you know what, just throw it at me. But a lot of other people don't want to be feeling motion sick or simulator sickness. So there's not really a hard limit. I know there's one person who spent an entire 48 hours inside of the HTC Vive and did a write-up on that experience. But I think we're only starting to see some very, very basic explorations, and it may be a little bit of time before we get hard numbers on how long people stay inside of the devices.
We saw the controls were largely about where you're oriented, how you move your face. What other kind of interactions are possible, and especially in terms of providing input?
Yeah, there are a ton of different mechanisms for input, and I could probably do another like 60-minute talk on virtual reality input. But in terms of the WebVR specifically, they generally will support controller input, whether that's a standard controller like an Xbox controller or a Bluetooth controller. They have hand controllers for the HTC Vive that they're tracking, and they can have a very specialized set of inputs for that specific device. But you also see things like Leap Motion, which is an infrared camera that does hand tracking, and they will track your fingers in space in front of you so that you can track, okay, I'm raising a finger, I'm doing a pinch gesture, and you can control virtual objects there through gesture input. At its most basic, the cardboard has a magnetometer inside of it that tracks whether or not you're pulling a magnet to replicate a yes or no binary input. But you've got, the keyboard and mouse, controllers. You start to see haptic devices that will track you and you can wear on top of you that have both an input and an output mechanism to them. The support of which generally varies from platform to platform. It's probably challenging to find a good haptic device for a mobile VR headset right now, but I guarantee you someone's working on it. So you have a lot of those types of inputs. I mentioned this briefly, that the HTC Vive has what they call lighthouse tracking systems that will track your full body in an experience and figure out kind of where you're standing. It doesn't do full body tracking to the extent where it can recreate exact body positions, but it knows kind of where relatively in the space you are with those controllers and can do some pretty interesting rendering techniques around that.
Hey, first of all, thank you. The second to last slide, you did have WebVR available on GitHub, and that made me curious if there are any other virtual reality projects on GitHub that you find especially interesting or that you're excited to see developed further.
Yeah, a lot of, so everything that I do, I put up on GitHub and open source because I'm trying to learn or teach by example and encourage people to have those resources available. That said, one of the most exciting projects that I've found that I kind of keep an eye on is an application called RiffSketch, which lets you write JavaScript code from within virtual reality. So you have a little console, and as you're coding 3JS code, it'll build everything around you. And so that's another one on GitHub that I've been exploring specifically. I have a GitHub repository that I can tweet out at the end of this talk because it's hard to name links. If everyone had an augmented reality headset, I could just throw that up there now for you all. But I have a GitHub repository where I track as many of the tutorial type projects or resources for learning virtual reality as possible. I mentioned A-Frame as being kind of a language, an extensible language for prototyping in WebVR very quickly. That's on GitHub that you can explore too. There's a lot of content that's starting to grow out, especially when I first started learning compared to 2 years ago, how much people are exploring this now and how low it is to start kind of prototyping and playing with this is really impressive.
So obviously gaming is up there with the VR technology. They've been doing a lot of the development. What would you say is the next industry that's really doing the most VR work?
I think there's a lot probably going on behind the scenes that people aren't talking about just yet, but productivity is a big one. There's a big push for more productivity applications to be able to work on our traditional applications in a virtual reality environment, and I know quite a few VR startups that are looking into how they can start enabling that as a regular everyday usage scenario. I think education and healthcare are going to be two other really big ones. We've already started to see how the healthcare industry is adapting to the new virtual reality technologies, and they've been an industry that's probably been exploring it for a while, since there's a lot of money in healthcare. There's also, I would say, education towards the lower end of virtual reality experiences is going to be a really big one. I know that with Cardboard, Google's got initiatives to do educational content and bring, virtual field trips, take people around the world, take them around the solar system, be able to engage kids into more immersive kind of learning experiences for them. And I think that that's, with the lower cost to entry for hardware in education, that's going to be a really big opportunity to adopt these technologies, and I think that's where we'll see a lot of impact too. All right. Well, thank you so much. If you have any other questions, come find me afterwards. I'll be around. I have got the device here. And if you have anything that I didn't cover that you don't want to, got to run off to another talk, ping me on Twitter. I love talking about VR, and I'd be more than happy to help. Thank you so much.